time we're gonna do that one using decimals, right? But anyways, let us read first what we mean by simple random sampling and some other terms, right? And some elements or components of simple random sampling, all right? Tree, let's read what random sampling is. Go ahead.
Random sampling is the process of using chance to select individuals from a population to be included in the sample.
Thank you, right? So, using chance, right, in selecting individuals from a population to be included in the sample, right? So when you say chance, each member of the population, or what we call individuals, right? If there are people, they're called individuals, should have an equal probability or chance of getting selected. Okay, and again, your sample size depends on your purpose for the research objective and definitely how big your population size as well is, right? Typically, if you want to have like a good formulation of conclusion from your research study, your sample size should be big enough, right, to formulate a conclusion. When you say big enough, typically 30 or more is the ideal number. Anything that's less than 30, typically we cannot yet formulate a conclusion because it might not be enough or significantly big enough to actually cover or represent the entire population, right? One more thing is the list of individuals in a population is called what? Starts with letter M. Starts with letter F. Guys, frame. Very good, right? So the frame is the list of all the members of the population, right? In short, these are the list of this is the list of the individuals, countries, elements of the population where you're gonna choose your what you call this participants from. Very good, right? Now let's read with this one. What is simple random sampling? All right, Robbie, go ahead, please.
Simple random sampling.
Yeah, there we go. Second, sample size and.
The sample size from population size n is obtained through simple random sampling. If every possible sample of size n has an equally likely chance of occurring, the sample is then called a simple random sample.
Thank you, right? So again, that's the key word in there. All members of the population has an equal chance or equal probability to be chosen as a participant for the said study. But again, due to ethics of research, definitely it's on the decision of the possible participants if they are willing to, volunteer to participate in the study, or they would refuse to be a part of the study as well. No matter how noble you think as a researcher the objective of your research is, if the participant says, I'm busy or I cannot be a part of the respondents of your study, then we cannot force them to be a participant. All right? Are we cool? Right? What else are the some elements of simple random sampling? We cannot repeat participants, right? So for example, if OB is already a willing participant for the study, then we cannot choose him again to answer a survey, right? We good? So you cannot treat a participant as double. We good? No repetition. What else? Be mindful of participant selection bias, right? For example, in a school like ours, right? Or in a campus like ours, there are students here in CAD, there are students there in the West Wing, there are students in PAP, there are students in Charlton Complex. So if you want to represent all the members of, say the entire student population of CVCC, for example, then what do? We go to each of the buildings, right? Okay. And do simple random sampling to each of the buildings. Are we good? By the way, that is what we call cluster sampling as well, if we are choosing by random which building would represent the entire population. But if you are choosing like all the buildings in the entire campus and getting students in there by random sampling, then that's still called simple random sampling. Are we cool? Right, so again, just be mindful of selection bias, right? For example, if you are talking about, once again, the entire student tree of CVCC, for example, the school, you cannot just concentrate here on this building without, keeping in mind that there are some other buildings that represent or within the campus. Are we cool? All right, what else? You use a random number generator. We gave you the table or random number generator table. This time we can also use technology. We're gonna use Desmos this time, okay? So let us read this problem and see how we can use technology to answer this one, okay? So where is it? Okay, let's read this again and see how we can work on the same problem that we did this problem last time using a random number, table of random numbers. This time we're gonna use technology for such, okay? So let's read this first. Obi, go ahead. Suppose the president
of the United States wants to hold a forum with the governors of 10 states. Use the frame shown to answer parts A and B. A, obtain a simple random sample of size 10 using table 1 in appendix A, a graphing calculator or computer software. B, obtain a second simple random sample of size 10 using table 1 in appendix A, a graphing calculator or computer software.
Thank you. So again, this time we're going to use a graphing calculator for this. Again, when we talk about a frame is what? This is the list of all members, not of the sample, but of the population. Cool. So in here, this is the entire frame, right? List of population individuals. And the big N is basically called our population size. How big is our population in here? All 50 states. Very good, right? Big N, that's the population size. By the way, I usually, excuse me, write population as pop N. Okay, just abbreviate it. Small n is the sample size. Very good, there you go. So when you say sample size, how big? How many respondents or participants do we need out of the 50? 10. Very good, right? That's correct. Okay, so we're gonna choose 10 out of 50, right? In short, in here, I would say the probability, right, that any member or any state in the United States, right, continental United States, can be a part of this study is what? 10 out of 50, right? So, which is what? Very good. So, again, the probability or the chance of any state to be a part of this, what's this? Forum is what? 1 out of 5, right? Good. Get it? Equally, right? South Dakota has 1/5 chance to be selected. Montana has the same 1/5 chance to be selected. Again, every member of the population has an equal chance or probability to be a member of this forum of 10 governors. Are we good? Right. Anyways, let's now use in here our graphing calculator. I'm gonna use Desmos for such, so you can go ahead and check it out how you do this on your end. So first of all, I'm gonna put in here random. So please put in random on your calculators. Again, graphing calculator. Put parenthesis and then put a square bracket inside. Right. So once again, let me just go ahead and erase that part over here. Okay. So random, parenthesis, square bracket. Inside it, you're gonna put in 1, 2, 3 until 3 dots, ellipsis, until the population size, which is how much? 50. All right, so this is what I'm going to put in here inside the square bracket. 1, comma 2, comma 3, comma 3 dots. That's ellipsis. 1, 2, 3, comma again, and your population size, right? 50. I'll be good. Right. So again, that is the list of individuals in the population, right? 1, the first member, the second member, the third member, until the 50th member. Are we good? Right. So plug it in your calculator, decimals. All right. Good, good, good. By the way, you are allowed to use decimals on our unit test, definitely.
Since it's random, will we get different answers?
Yes,
Okay.
that's correct, right? A good question in there. So as you type it in there, I already got what? A number in there. It says on my end 35. Again, that's why this is random. Which means you might have a different number on your end. Again, that's why it's called random, right? Definitely, you're not gonna get 35. Honestly, it's a lesser, you know, output for you than 35. Are we good? Okay. No, even if you don't put enter, you always would say see a number in here right away, right? So after that, I'm gonna put it in here, 35. You good?
I don't see a number of mine.
You see a number of yours? Let's see, okay? Oh, because you're using curly bracket. Make sure it's square bracket, alright? Again, parenthesis and then square bracket, alright? Do not use curly bracket because it's not gonna work, alright? So make sure that the syntax is right. Parenthesis first and then square bracket. Anyone else who didn't see any number on your end? Everyone got it? Okay. So again, I put in 35, so I'm gonna put it on the list, okay? What else? So this is what I'm gonna do. I'm gonna click in here. It's gonna select another random number. I got what? 36. Okay, so again, it just so happened that it's there one after another, right? Now I'm gonna click one more. 30, right? So I got 30 there. And then I'm gonna do that one how many times? 10 times, right? Because again, you want 10 numbers to represent your population, right? 39, 48, so how many do we have now? 5, right? 24, 44, 42. So how many now? 1, 2, 3, 4, 5, 6, 7, 8. 2 more, right? 22. Oops. 42. 22. Last one, 4. There we go, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Are we good? Right. So again, since this is a random number generator, definitely you're gonna get a different set of numbers as well. Are we good? Right. So once again, those are my numbers. Let's put it in here on who my sample will be later, right? Put it in right, okay. What's that again? 35, 36, 30, 39, 48, 24, 44, 42, 22, and the last one is good. Get it? So again, let us go back to the problem and let's see who are my possible participants or members of the forum. Let us highlight them in there. 35, which one is that? What state? Ohio, right? Or 36, what state is that? Oklahoma. Again, as you may notice, our frame is listed alphabetical order. Okay? 30,
Which one is that?
New Jersey. 39, Rhode Island. 48,
West Virginia.
West Virginia.
No.
24, where's 24?
Mississippi.
Mississippi. 44, where's 44?
Utah.
Utah. 42, Tennessee. 22,
Michigan.
Michigan, right? And 4, Arkansas. Good. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So, do you think we are mindful of some bias or possible bias for participant selection? Yes, we are mindful, and as you may notice in here, we didn't have any bias at all on in terms of like selecting our participants, right? Everyone, all our states has an equal chance, equal probability to be selected as a member of the 10 state forum, right? What else? Did we use a random number generator? Yes, we did. We actually did use a Desmos random number generator, right? What else? Well, first of also, as you may notice, it doesn't really matter how big the state is or how much population they have on the state. We didn't consider those, right? We just considered no matter how small the state is, which is the smallest state. I think Rhode Island is the smallest state, right? Which one is the biggest state? I think either California or Texas is the biggest state. It doesn't really matter. As long as by political geography, they are, you know, a state, considered a state politically, then we consider them as one member of the frame. Or possible, or 1/5 chance of probability getting chosen for what? Being chosen for being a member of the 10 state forum. Are we good? Get it? Again, we didn't consider any aspect of those states, right? Because you might be thinking, well, Mr. Deal, I mean, say, which one is the most populous state? I would say